Hello, welcome to Conquer the Concept, and in this video we'll be learning all about circles. To start off, I wanted to give some basic terminology. The first was the radius. And the radius, by definition, is a line stretching from the center of a circle to the edge of a circle, and that edge can be any edge. So, for example, in the image to the left, we can see that this line is called the radius, and it doesn't have to be in only that direction. It can be in um, this direction, anything. So it just has to go. It just has to start at one point. Has to be on the center of the circle, and the other on the edge. The next term I wanted to talk about was the diameter. And the diameter is always twice the radius. And what that means is that the diameter has to have one point on the edge of a circle, the other point in the center of the circle, and the third point on the other edge of the circle, opposite to the first point. Basically, it's a line that stretches from one edge of the circle through to another edge of the circle that passes through the center. So, and it also doesn't have to go through just in this direction. It can be here, here. So, yeah, the radius and diameter are really important when we're discussing circles. The next thing I wanted to talk about was the area and circumference. The area is basically just how much space a specific shape takes up. And we use different formulas to find out what the area is and how much space a shape takes up. For example, in squares and rectangles, we just multiply one side times another and we can get the area. However, in circles, we have to use this formula. It's pi r squared, where r is the radius and pi is 3.14. And I'll address pi a little bit further along, but it's not really essential to know what is exactly what pi is right now. So, we put it in side note, pi is 3.14. In reality, pi is a irrational number, which means that it's like it never ends. But mathematicians just use 3.14 for easiness in multiplying. So let's do an example problem. So let's say I have my circle here, and I have the radius, which is 3. So to find the area, I would do pi times 3 squared, which is equal to 9 pi. And since pi is equal to 3.14, we could do 9 times 3.14, but most questions actually will ask you to solve and put your answer in terms of pi. So this would be the correct form. Now let's discuss the circumference a little bit more. Now the circumference is 2 pi r, or d times pi, and that just means, and the circumference is just the perimeter of a circle. We just call it a circumference. And to be more detailed, if you have a fence, the circumference or perimeter would just be the amount of fence that you had. Let's say you had you were enclosing a couple of animals in a fence, and they asked, how long is your fence? And that they would be just asking how much is the perimeter, or what is the circumference. Now 2 pi r, or d pi, and 2 pi r, again, the r stands for the radius, and then d pi, the d stands for the diameter. So we learned earlier that twice the radius is the diameter. So we're just substituting 2r with d here, and we're keeping pi the same. So they're the same thing, essentially. You can use either of them. Let's say we had a circle here, and let's say a diameter of 10. Now our circumference would just be 10 pi. It's as easy as that. So we now have learned the terminology, and the area and circumference. Now, I wanted to move on to arcs. Arcs are used to find what a specific area or perimeter of a circle is. Let's say we have this arc here. So in this arc, we have a circle. We know that the radius is 4, and we have this this kind of L-shaped line and this degree is 36 degrees. So we know that and the question mark is asking us, what is the length of this part? We know that a circle in the center of the circle has a degree of 360 degrees. So we can set up a ratio to find out what this question mark would be. So the ratio would be this 36, the length of the degree of the arc, divided by the total degrees, 36, and then you would put an equal sign, and then we wanted to find out what is the length of the arc. So we'll just keep that a question mark. And then what we have to do is, because we're doing the arc over the total, we have to keep in the degrees, so we have to do the arc over the total in the length too. So we learned from earlier that the circumference of a circle is 2 pi r. And you would just do 2 pi r. And now this is what we could use to solve for the question mark. And we know that the radius is 4, so we can just substitute. We could get 36 over 360 is equal to 2 pi r, and 2 times pi times 4, the radius is 4, and then we would get 8 pi. 8 pi, and we could simplify this 36 over 360 to 1 over 10. So 1 over 10 is equal to 8 pi. And if you know how to solve basic ratios, then you know what we would do is 8 times 1 divided by 10. So 8 pi times 1 is 8 pi. And 8 pi divided by 10 is just 0.8 pi. So you see how I didn't really have to expand the pi and then divide by 10, because it's not needed. So what we can just do, if we leave the pi there and just automatically bring it up, we could just do the same steps. So yeah, so the length of the question mark is 0.8 times 3.14, or pi. And then the circumference of this the total circle is 8 pi. So we could find the arc length using a simple ratio. Okay, the next thing I wanted to talk about is still arcs. However, instead of finding the length of an arc, we're trying to find the degree. So let's look at this problem. So we know the arc length is 6 pi, and we know that the radius is 18, and we're trying to find what this x is. Once again, we know that the total degrees in this circle is 360. So, and we're trying to find the specific degree of the arc. So x, which is the degree of the arc, over 360 is equal to the length of the arc over the total circumference, or the length of the total circle, if that makes more sense. And once again, we could just simplify first and then solve. So x over 360, I'm just simplifying in this step, is equal to 6 over 36 can be written as 1 over 6 as well. And basically 1 pi over 6 pi. And the pi's, as we discussed earlier, aren't really needed. So we could do 1 times 360 and then divided by 6. So 1 times 360 is just 360, and 360 divided by 6 is 60. 360 over 6 is 60. So the length of so the degree of the arc is 60 degrees. Yeah, so now that we've discussed arcs, we can go to optimization. Now I made a really in-depth video of optimization. And basically, to sum that up, that the circle is the most optimal 2D shape. So what that means is optimal means in when we're talking about shapes means it's the most area with the least amount of perimeter. And if you want, I can you can go watch that video. Yeah. So now we're gonna talk about a little bit more terminology, and this is kind of higher level terminology, and it's not needed right now. So here, this black line that I'm hovering over, you guess what that is? It's the diameter, and that's one of our basic terminologies. Let me just abbreviate that. And this line here is called the radius, and we talked about that earlier. However, we have three new um terms to know. So the red line is called a chord. So it's not CORD, it's CHORD. And then this green line here is called the secant. And then this blue line here is called the tangent. Yeah. And now that's just some more terms to know. And I hope you learn from this video. If you did, please like and subscribe and comment down below. Thanks for watching.